Okay, everyone. Thank you for joining this session. Today, I would like to discuss with you the topic about outdoor wireless design. I'm Erkens. I'm the business owner of Wi-Fi Engineers. We deploy several outdoor solutions once a year. These are not your typical deployment if you compare that to an office building, for example. So I'm going to take you on a journey and try to give you an insight on the issues you might be running into, or some design considerations you have to make. It's always the technique that needs to. Yeah. Or in this case, Bluetooth. Yeah, very good. Some use cases for Wi-Fi in an outdoor environment. You can find an outdoor Wi-Fi environment in industrial environments, like a plant that has HEVs running outside, but also in public spaces, for example. Leisure and hospitality, like campsites. This is where you quite often see a Wi-Fi environment nowadays. Harbors, for the guests that arrive there, and also during events. Now, before you start to do your design, make sure that you understand the customer's expectation. Because a lot of the user experience in the end will depend also on how the customer expects that the Wi-Fi network needs to work. Understand also how the Wi-Fi is being used. In a hospitality environment, the users are going to use your Wi-Fi differently than a production environment. And try to understand what kind of clients are being used there. Because based on those decisions, you need to make a design. Also, try to identify possible sources of interferences. This is quite often overlooked when someone does a design in an outdoor environment. And one really important thing is, go on site. This is not your typical design which you do from your desk and say, okay, I got the drawing, let's make it and roll it out. There might be some interferences. Quite often we think of interferences like maybe Bluetooth, Zigbee, non-Wi-Fi devices. But in an outdoor environment, you might see neighboring networks. Those neighboring networks might not be designed really properly, so channels that are used might not be 1, 6, 11, maybe 4, 5, 7. Those things can cause adjacent channel interference, and you need to keep that in mind. So it doesn't affect your Wi-Fi network. There are also some less known sources of interference. For example, wireless backhauls. Maybe someone already has a wireless backhaul installed, which means that specific channels might not be useful there. Radar signals. These can also affect your wireless environment. Especially when you look to marines, harbors, and near the coastline. Radar signals can affect your wireless network, so keep that in mind. Also air traffic. You don't need to be near an airport, but if you're in a flight path, then that might also affect your wireless network. For example, here, it's a nice place, quiet. Somehow, we're seeing some DFS hits here. Of what might be the cause. Sometimes one of the neighbors is passing by. Is testing out his chopper. So these things are things you need to try to identify upfront. Ask your customer, hey, can I expect maybe planes flying by? It might not be the most usual question to ask, but these things do happen, and they will affect your wireless design. When you start to prepare your design, it's really important that you try to work with accurate sources for your design. You can use satellite imagery, like for example Bing or Google Earth Maps, or some geographical information system, or maybe use a CAD drawing, or maybe use a drone image. So try to find out which source gives you the best accurate overview. That's also why it's important to go on site to see how the real environment looks there. You also need to keep in mind, how am I going to design my backbone infrastructure? It's not simply putting in a few APs. The data needs to come from somewhere. It might need internet connectivity or connectivity to the network. You might go for a wired option. So a few things you can consider are using fiber, traditional Ethernet solutions, or maybe a GPON solution, or maybe a hybrid solution where you use fiber and combine this with Ethernet. Or maybe choose a wireless backhaul. There are several options which you can use to deploy a wireless network. One of them might be mesh, or maybe use point-to-point or point-to-multipoint links. Let's take a closer look at mesh. What is actually a mesh network? A mesh network is a network in which access points are wirelessly connected or linked together to form their own backbone. There are some advantages to using mesh technology. And one of them is cheap and easy to deploy, but there are also some disadvantages to using this technique. And one of them is a single channel architecture. This means all these APs are sharing the same channel. So co-channel interference is something that will affect your network. Performance is also a thing. As you can see here in this example, we've got one AP, it's called the root AP, and after each AP we have another one connected. So the first hop, we might have 100 megabits throughput. On the second hop, with every hop, the throughput decreases. In this case, by a factor of 2. So 50 megabits. On the third hop, we might have still 25 megabits. The client which is around this first AP, or last AP, might still have a data rate of approximately maybe 300 Mbit. But due to the fact that we're having an infrastructure that is meshed, we're constantly decreasing the throughput of the network. And that's why it's important to not use more than 3 hops in a row. Mesh can also cause SSID overhead. A lot of these solutions have the ability to join an AP wirelessly without having them first connected to the network. So what they do, they create a hidden SSID, and once a device starts to join, you might see suddenly a network name pop up, in this case, the mesh name. Now imagine if you're having 50, 60 APs in your outdoor environment, and they are all having mesh enabled because it's a default feature in the product that's available there, it will eventually cost additional SSID overhead. That wasn't me. And also keep in mind that if you're using a DSF channel and a DSF event occurs, you might see a large outage because quite often it will take some time before those APs are rejoining the neighboring access point. Point-to-point or point-to-multipoint solutions. They offer some advantages. They offer better performance than mesh networks do. They often require less digging if you compare it to a fiber network that needs to be deployed, and it's quite scalable. There are several solutions out there. One of them might be a 5 gigahertz solution. These solutions are affordable, quite inexpensive nowadays. Some products also give you the ability to use GPS sync, and where do they use the GPS for? It's not for positioning, but they use it to determine when which device is allowed to transmit it. They are using time windows. So actually there's one function they are using, that's the clock of the GPS. You might also choose 60 gigahertz solutions. One big advantage 60 gigahertz offers is it doesn't interfere with your wireless. It's a completely different frequency. It offers also high throughput. In a point-to-point situation, you can nowadays have up to 10 gigabit throughput. Or you can use a point-to-multipoint solution and have a 1 gigabit, maybe more backbone. It's important to know that all these technologies which require high throughput are quite often using those GPS sync technologies. This is, by the way, a solution which you can see here that's based on the 802.11 AY standard. Those equipment should be able to work with other vendors, but I haven't tried it, so your mileage may vary. There are also some disadvantages when you use these solutions. They require a 3-line of sight. The fractional zone, I will come later to this and explain to you what the fractional zone is. It needs to be free of obstructions. It might require higher grounds or maybe a tower for this to be installed on. And you might need to have additional equipment to properly align and install these equipment. You might also need to have an engineer which is not afraid of height. And one of the things I've run into in the past is that the combination of using point-to-multipoint solutions together with a mesh or a network that has mesh enabled, that you might run into a spanning tree issue. Suddenly, a AP that is meshed starts to think, hey, I've lost connectivity, or I have a wired side, basically a non-mesh network, but I decide to be a mesh network. So that can cause eventually a loop in the network. So you're connecting wirelessly, while on the other hand, you're connected wired to a wireless backbone. If you're doing a 5 gigahertz solution, you need to keep in mind that you use dedicated channels for this deployment. And when you try to align 60 gigahertz equipment, it might be a bit more challenging than where you do typically 5 gigahertz deployment. The angle which are used for the beam width are quite often around 2 degrees when you're talking about 60 gigahertz solutions. If you compare that to a 5 gigahertz solutions, you might often see a 15 or maybe 30 degree angle. Over 100 meter distance with a 2 degree angle, this means you can be off by 1.5 meter to the left or 1.5 meter to the right. So it can be a bit of a challenge to get everything properly aligned. So take your time when you want to deploy 60 gigahertz point-to-point link. Now, let's take a look at what the threshold zone is. It's important that it's free of obstructions, as I mentioned before. The signal that's being transmitted is not something that's in a straight line. As you might see here, in the middle, the signal is wider than at the beginning and at the end. It means that we need to keep this part in the middle free of any obstructions. Depending on the solution, you need to have clearance of approximately 60%. In this image, as you see here, this mountain is obstructing the signal path there. To solve this, we might need to raise 1 or 2 of our dishes. Let's take a closer look here. We've raised these dishes from this side, they'll stay on the same height, approximately 3 meters. But on the left side, we moved them almost 2 meters up. Now we've got clearance. But still, we're having, as it shows here, from the ground, 0.2 meters of clearance. Now in case this crosses a road and a truck passes by, we're still getting obstructions there. So keep in mind, flood toilets between there, vegetation or a road, you need to steer clear of that. So make sure you've got enough height. Or you might consider using a different solution there. Higher frequencies means that we are having a smaller diameter in the middle of our pressure zone. In this case, the installation height for the 5 gigahertz solution is the same as for the 60 gigahertz solution. But we've got already now 1 meter more of clearance at the same point. So keep that in mind. If you're using a 60 gigahertz solution, you will need less clearance than you need for a 5 gigahertz solution. And this becomes important when you're running a link over a longer distance. For example, maybe a kilometer or even more. You might have some design challenges. Elevation heights, that could be a thing you need to put in consideration. Changes in vegetation, winter, summer periods. Recreational vehicles, for example. Let me quickly point it out. As you can see here, there is here a camper standing. We've got here AAP. Now if we take another look at the same image, as you can see here, here is our AP, here is our camper. This camper here is not your standard typical camper. This one is based on a truck. So if you're installing an AP which is not high enough, then you might have a reception issue there. This camper which is standing here has a typical height of 3.2 meters. This one is around approximately 50 to 75 centimeters higher. So you need to keep that in mind. If your customer, for example, has that kind of customers using this property, make sure your APs are installed high enough. So the installation height does matter. Yes?
How would you address requirements of customers wanting to have Wi-Fi signal inside the caravans?
I can point it out with that image here. So this is a new situation, for example, where a new network was being created. And in this case, we chose to bring in the network into these cottages. And why we did that? Because almost, from my experience, you're going to have issues when you expect that the guest can have a proper wireless experience within a cottage. You're having signal loss when it needs to travel through the walls, and that will cause eventually issues. So if you want to do it right, then you need to have an AP installed on the inside. So keep that in mind when you are planning to do these kinds of installs. So I hope it answers your question. Yeah. If we take a look a little bit higher here, we've got here a tent. This is for a corporate event. I don't see any issue there by bringing in a wireless signal from the outside into the tent, because the fabric that's being used there will not attenuate that much if you compare it to the cottages which we're seeing here. Also, when we look at, for example, an outdoor deployment, you might see more CCI or adjacent channel interference. And this is because of the fact there are quite often less things that can attenuate the signal. And also keep in mind, sometimes you might have to consider a river that's somewhere between. So if you're doing a point-to-point link, and during the winter it starts to flood, you might need to have an additional 2 to 3 meters of clearance. So keep that in mind. Some considerations. So when we do a deployment or design for a customer, we tend to aim at -65, -67 dB. It all comes down to your requirements, but this is what we quite often design for. We try also to keep CCI as low as possible. We need to keep in mind that it might change over time. During a winter period, when there was no vegetation, you might see more co-channel interference than during a summer period. It also has influence on your received signal strength. When there's nothing to attenuate, the signal will propagate further. And try to design for the highest possible data rate. One of the things is also, you can go for, let's say, 40 or 20 megahertz wide channels. Depends on your situation. But if you want to design for a high performance, try where possible to move to 30 megahertz until you come to the point where you say, okay, this isn't going to work, I need to go back to 20 megahertz of channels. And also exclude your 5 gigahertz channels when you're going to use a point-to-point or point-to-multipoint network. Don't combine them. It will affect the performance of your Wi-Fi network. And also try to disable low data rates. From my experience, disabling less than 12 or even less than 24 will help to improve your wireless network. Now, at some point you also need to validate your wireless network. When you try to validate, try to do this under real conditions. Let's assume we have a campsite. We've done the deployment in winter. Does that really represent the real circumstances? Maybe we went with just an open field, while in the summer there are a lot of caravans, campers standing there, trees, They have leaves on them, so keep that in mind. So when you try to validate, try to do it under real conditions. How to validate your design? Use your favorite tool. Depending on what you have, it's important to use a tool that gives you the insight on how your network performs. And also, if you're doing these auto deployments, try to use GPS. But if you're using a GPS, try to look at how accurate it is. There are some GPSs out there that have a large amount of drift. With drift, they are constantly moving from left to right, compared to the position where you are. So if you have a drift of 5 meters, the GPS coordinate might be 5 meters to the left and suddenly 5 meters to the right. So try to use a GPS that has minimum drift there. And outdoor environments are quite often large spaces. So if you want to do these surveys efficiently, try to use, for example, a TV like we do, or use a golf cart, or maybe use a Segway. But keep in mind, don't go too fast, because the data points need to be gathered, and for an accurate survey to take place, from our experience, you shouldn't be crossing 15 kilometers speed. I want to thank you for your attention here. If you have any questions, feel free to ask. Yes?
Are you allowed to use 60 gigahertz point to multiport now in the Netherlands?
Yes, you are allowed.
Is it changed?
It did not change. The FC domain already allowed it several years ago, but due to some wrong implementation, to say it that way, within the Dutch laws, it was not fully documented. And nowadays it is allowed. So you can legally deploy 60 gigahertz solutions. Any more questions?
Do you typically disable BFS channels?
No.
No?
No. I try to reuse those channels where possible. But it will depend on your environment. If you're having a situation where you're near the shore, for example, and marine radar can affect your the performance of your network or cause outages, you need to take a closer look at which frequencies are most affected there and try to take them out. You can do that afterwards, but it will affect in the beginning your network, or try to do your homework up front.
Yeah. All right.
Any more questions? No? Thank you very much.